Question 9. What is the x-coordinate of the point of intersection of two graphs of the functions? They are both linear functions. Their graphs will be lines. I don't need to write y alone. I can apply logic of solving system of equation with two unknowns. You may use ordinary method to solve. To cancel y, I will multiply second equation by 4. The first equation is 3x minus 4y is equal to 7. After multiplying by 4, the second equation is 4x plus 4y is equal to 20. If we add side by side, sum of x will be 7x, sum of y will be 0, sum of numbers 27. If you write x alone, 27 over 7 is answer. Answer of question 9 is B. Question 10. Points of intersection of the graphs. One of them is a quadratic equation, the other one is a line. So let me write y alone. The first equation can be written y is equal to 7 plus x to the power of 2. The second equation can be written x plus 1 is equal to y. The two functions will be equal to each other. So y is equal to y. Y is equal to y. 7 plus x squared is equal to x plus 1. Write all the terms to the same side. X squared minus x plus 7 minus 1 is equal to 0. X to the power of 2 minus x plus 6 is equal to 0. If I want to use 3 and 2 to get negative x, negative, positive should be used, but it is not going to give us 6, so there is no factoring. Factorization doesn't help us, so we are going to use delta. Discriminant is b squared minus 4ac. Delta is a is 1 minus 4 times b is the coefficient of x, which is negative 1. C is the last term constant, which is 6. 1 minus b squared minus 4ac minus 4 times a is plus 1, sorry, a is plus 1 times 6. 1 minus 24 is equal to minus 23, less than 0. So we cannot find any solution. If there is no solution, no x means no point of intersection. Question 11. Points of intersection again, and I can use same logic. Y can be written 6 minus x to the power of 2, and in the second equation y can be written as 4 minus x. If you equalize the two functions, 6 minus x to the power of 2 is equal to 4 minus x. Take all the terms to the same side. 0 is equal to x squared. Negative x, there is plus 4. 6 goes with minus sign. 0 is equal to x squared minus x minus 2. So x minus 2 times x plus 1 will be the factors. So first solution is 2. The other solution is negative 1. 2 and negative 1. 2 and negative 1. I can say answer is C, but what is the best way? Write 2 in one of the function, which is easy. y is equal to, if I use the second equation, 4 minus x, 4 minus 2, 2 and 2 is one of the point, negative 1, 4 minus negative 1, so negative 1, and 5 is the other point. Answer is C. Question 12. Points of intersection of two functions. Functions are rational functions. My logic is the same. I have to write f of x is equal to g of x. X to the power of 2 minus 3 over x to the power of 2 plus 1 is equal to x minus 3 over x squared plus 1. They are both rational and we are equalizing them. To find the solution, pay attention, denominators are the same, so you may cancel the same denominators from both. Let's focus on the remaining equation, which are the numerators. And in the numerators, we are also going to see negative 3 is a part of each equation, so I can also cancel negative 3 from both sides. The last equation is x squared is equal to x. I cannot cancel x, it doesn't work, so I have to collect all the unknowns at the same side. X squared minus x is equal to 0. X can be taken as a common factor. X times x minus 1. So there are two solutions which are 0 and 1. So I am looking for points 0 for x, 1 for x. You may also write 0 in one of the function. If you write 0, negative 3 over plus 1 will be negative 3. If I write 1 minus 3 over 1 plus 1, negative 2 over 2 becomes negative 1. Answer of question A, 12 is A. Question 13 will be used to answer the graph will be used to answer question 13. F of x is equal to g of x. It is not written, it is written like f of x is equal to g of x, but whenever I see this writing, I am going to remember points of intersection of two graphs. If we pay attention to the given graph, function f is an upward parabola, function g is a downward parabola. I am looking for, is there any common point? I couldn't see any common point of the given graphs, so there is no point of intersection in the question 13.